Welcome to the Anjarati studio at European Utility Week. I'm joined by Reza Mirkhani, President of Enverv. And Reza, thank you for making the time to be here today. We've dragged Reza off the show floor to be with us in the studio. And Reza, your company has just launched a new chipset, showcasing it at the show. Tell us a little bit about what that enables utilities to do and some of the uniqueness that you feel is inherent in that product.
Sure. So first off, let me thank you for having me here. Yes, we have launched a new chipset which is targeted at AMI metering infrastructure. And the chipset is very unique in the sense that it is optimized in a way both for the revenue protection market, which forms half of the AMI market, and the energy efficiency market, which is the other half. Both of them have different needs, different requirements. However, both these markets need what we call mission-critical connectivity.
And do you see, I mean, we've just been doing some research into this market. Do you see the increasing proliferation of the need to run data and protect that data layer within the grid as becoming an increasing demand that people are coming to you to solve? Or
Indeed. So the challenge has been so far in many parts of the world to reliably, first of all, get the data from the meter to the utility. And that's hence the terminology mission critical connectivity. And many different utilities and meter maker and system integrators have taken many different approaches to solving it. Initially in North America, we've seen how they go about introducing RF mesh. And their fundamental reasons why North America had to resort to RF mesh was really because there were no advanced PLC technologies at the time that they were actually planning the AMI network. Then you look at elsewhere in certainly the revenue protection market, where they are trying to do load shedding dynamically, both for reasons of non-payment and also in countries such as South Africa or Brazil, where the GDP is growing, economies, and industries are picking up. So the power consumption and power demand is outpacing power generation and expansion of generation capability. So in most markets, they do need mission critical connectivity is what we call it. It's called guaranteed access to every node on the power network under any condition. In energy efficiency markets such as Europe, North America, and Japan, for example, they are actually trying to fine-tune the power generation to the demand. So they want to avoid over-purchasing of power to try to optimize for peaks. And this is peaks in demand and what they call demand management and so on. Having said all of that, what all of these utilities and meter makers have essentially tested is different technologies for implementing the AMI network. We believe that with the latest generation of power line communications that we have been able to demonstrate and field test globally, we have been able to deliver what utilities are actually looking for, which is guaranteed access to that node under any condition.
And you do that by essentially transmitting data over the very same network that's transmitting the power. So the power line network.
Exactly.
It's similar to the new devices that we have in our homes now, where you plug in a modem into one electric switch and then go to another one, and that
is right.
To put it into context. So in terms of that and making that mission critical, does that not need another failover? I mean, what if the power line goes down? Does that kill the data? Or are you saying, well, then you've got a different issue and actually...
So there are many different cases. You bring up a good point, actually, which is, let's say you do a load shed, you cut a customer off for non-payment. What do you do then? Well, those customers typically have a display unit in the home. So that display unit will still communicate over the power line, even though the disconnect relay has been activated. In the case where you have outage in a city, a neighborhood. If you have outage, you have to have a truck roll anyways. How do you know you have an outage? The system architectures are such that you're constantly doing a roll call of who is present on the network. And the minute you lose a node or someone is not present, or when you see a group of nodes are not present on the network, that's a clear indication that there's a problem. You have to send someone to check it out. Now, an interesting argument that a lot of wireless technologies bring up, they say, oh, well, fantastic, we have a meter with a battery in it, and when the power is lost, it actually tells the utility that, hey, I lost power, I don't have power. What do you do then? You have to send a truck to that node and go and figure out what is going on. With power line communication, you effectively do the same thing. It's just by knowing that you're not getting signal from a meter, you actually know that there is no power. And when you have a group of meters that they are disconnected, then there's a problem.
Chances are there's a bigger outage. So one of the things that's come up with some of the research that we've been conducting and actually looking at the sessions that are happening here, all of these technologies like your chipset, which are being put in place, are generating massive amounts of data.
Yes.
And there is an argument, and I want to ask the question because we haven't really decided one way or another, and wonder whether you think it's overhyped. But a lot of people are saying, well, with this explosion of data, and there is an issue about the software solutions and the business or the intelligence solutions to be able to react meaningfully and get something intelligence out of that mass of data. Would you corroborate that? Do you think there's a gap there for that, or do you think it's one of those things which are...
Well, it's a very subjective topic, quite frankly. You're right, there is a ton of data that is being generated that is going to be generated with all these AMI networks being in place. What will utilities or everyone do with this ton of data? That remains to be seen. What we know that they will do is certainly the demand response is something that they can benefit from. They can optimize their power purchases and fine-tune it to the power demand. That is something that they can collect data over time. You get your statistical distribution, your bell curves of consumption over different periods of time, and you also get that data instantaneously. So you kind of have a profile of what you will expect on a hot day, on a cool day, on a day that's at 90 degrees Fahrenheit versus a day that's 80 degrees Fahrenheit. So you have those profiles on a region by region, neighborhood by neighborhood basis. And you can certainly put that data to use and fine-tune your purchases. What will utilities do above and beyond, quite frankly, I don't know. But I'm sure that anytime you collect so much data and you store that data, there will come a variety of different applications for mining that data and making use of it. What we see in places like South Africa, like Brazil, where utilities are actually getting very creative and they are giving incentives to customers, for example, to give them access to the water heater, to the pool pump, and to the air conditioning unit, so they can again control peak demand. And these accesses are not destructive, in other words, not destructive to the consumer.
So they're basically saying, let me know, or give me the ability to let me know when you're turning on your aircon and all that
Exactly.
sort of stuff, so that I can be maybe a little bit more. It's that old analogy we had in the UK where everybody turned on the kettle at the same time.
That's right.
You want to avoid that.
That's right.
Yes.
You want to avoid that. And what they can do is, for example, the water heater, they'll just lower the thermostat by 5 degrees, or your air conditioning, maybe they'll lower the thermostat by 2-3 degrees. When you do that grid-wide, then you actually have a significant impact, and there is a benefit, and they can avoid that peak and avoid any potential rolling blackouts and so on. So all of these could be done in much finer granularity when you have real-time data. And So for all of this to work, naturally, you need to have robust, reliable communication in place. And when you look at some of the newer technologies that are being adopted in different parts of the world, is you have the prime standard, the G3 standard, and what we call the 4G PLC standard, which is really an evolution of all of these OFDM-based standards. These standards are all implementations of technology that is fairly old, I must say. OFDM communications, which is what all of these standards are based on, it's actually from the 60s.
Yes, yeah.
And so OFDM itself is not new. Implementation of it, however, is actually very new, and it's getting more and more advanced. And you look at LTE network, which carriers in the wireless space are rolling out. Those actually employ the latest and greatest techniques of implementing an OFDM-based network, and they're quite effective. So what we have done certainly in 4G PLC is we've looked at actually the shortcomings or the gaps in the existing standards such as G3 PLC and Prime, and have filled those with some very advanced algorithms, much of it borrowed from satellite communication and cellular communication, and also other broadband communications that are based on OFDM. So once you really incorporate all of that, then you can deliver the same level, the same sophistication that you see in latest LTE networks, for example, in the cellular space to the smart grid. And this is something that Enverv is really doing that other companies have not yet invested or decided to do so.
So if you're seeing that opportunity, would it be too much of a stretch where, you know, there are regions in the world where it's not just getting electricity there, we want to try and push other communications out there. Do you think that your technology has the capability to give enough bandwidth over a smart grid where you could actually put other services down the same pipe?
So the technology itself is very scalable depending on how you architect the network. The more you subdivide the network into smaller sub-networks, then you will have higher data rates available to each network. Very much like, like the cellular network, where the cell sites, as they shrink, then you have more capacity network-wide. And this is very similar to that. Now, the uniqueness of our technology is that we can actually address rural coverage much better than other technologies. We have demonstrated connectivity over distances of 150 kilometers in the rural areas, where we actually couple to the medium voltage. And with our capability to traverse the transformer at a very good data rate, and then we can actually service a very large area, 150 kilometers in radius. You can imagine pi r squared, and you actually get a very large coverage. So in that sense, we bring connectivity and node access on the grid at a very very cost-effective price points, where you don't need to go and put data concentrators, you know, in all these different places on the network. You can actually service these with one data concentrator. Because keep in mind, the hardware itself doesn't have a whole lot of cost to it, but it's actually sending the truck out there, the truck roll, the personnel, all of that which it entails actually getting a unit commissioned, installed, and bringing it up. The costs will add up. To give you an example, in a country, for example, such as France, where it has 35 million nodes, 15% of those nodes are rural. The capability that we can bring in with our technology can save the utility ERDF, for example, in the neighborhood of a couple $2 billion for just rural coverage.
Which is not insignificant.
Not insignificant at all.
When people are trying to cut their costs. Reza, we're nearly out of time, and I'm asking all the people who are interviewing this question. I mean, this is clearly a massive event
Yes.
we've got here. And if you were to say to someone who's coming here, what are the few things that you've seen that have interested you? Because you've clearly been in the industry for a while, so your opinion holds weight, I would imagine.
No, thank you so much. Well, things that actually interest me personally is some of the newer technologies and newer companies that are emerging in this space. You know, sort of the Internet of Things that is coming about. As the smart grid goes into place, you know, and meters are really at the heart of it, then above and beyond the meter to utility communication comes the communication within the home. You know, the fact that you can turn on an LED light from your smartphone or operate your entire house, that really is the next phase of growth. And I think we're going to see many, many interesting applications and many useful tools that are going to emerge in the space that not only just focus on energy efficiency, but really consumer integration into the smart grid.
And I think that's one of the key points. The consumers need to be brought along on this entire journey. Thank you again for making the time today.
My pleasure.
Pleasure to have you here.
Thank you
for watching this interview. There are many more in the series. We'll be releasing them over time, and I hope you enjoyed what you heard today. Thank you.